Hello. Hello. Okay, good morning. Alright, the audio and video seems to be on. I'll assume that you can see the screen. So today we'll continue with the histology of the female reproductive tract. Last time we had finished the gross anatomy, the morphology as well as the microstructure of the ovary. And after that you've had 2 classes on the uterus and I think the fallopian tube, right? So since you finished the morphology, let's continue with the histology parallelly so that all of it stays together in your head. And after some time, after we finish the entire abdomen and pelvis gross morphology, we will go to the further aspects of the female reproductive tract, which include those which come into activation after pregnancy, which means the placenta and the umbilical cord and the mammary gland. So we will look at those 3 at a later date. Today, let's just look at what is left of the internal genitalia, which you have seen in gross morphology but not yet seen the microstructure of. So we'd already looked at the ovary and all its development, as well as all the kinds of follicles, the kinds of development and the types of structures you're likely to see in a slide. The next organ in terms of the path of the ovum is the fallopian tube, which we saw the gross morphology of yesterday. We will look at the microstructure today. And then the next one where the ovum will arrive and nidate is the uterus, which also you looked at as a gross anatomical female reproductive organ. We will look at its microstructure and the changes it undergoes with each stage of the ovulatory cycle. Then we also have the cervix, which is the lower part of the uterus, which you saw in yesterday's class, but we don't have a separate slide for it, but it does have a different microstructure because in its function during pregnancy, it has a completely different function from the upper 3/4 of the uterus. There's an upper segment and a lower segment in a pregnant uterus, which is a different phenomenon both structurally and functionally. This cervix opens into this muscular elastic tube called the vagina, which of course has a different histology, but we won't be looking at that. At undergrad level, you don't need to know that in great detail. We don't have a slide of it for you. But these 3, ovary, fallopian tube and uterus, you should be able to recognize under the microscope, as well as to be able to discuss in an exam or write a note on for theory or spotters. Identify it immediately when you look at it under a microscope. So let's look at these in detail. So after the ovary, the ovum we know enters into the fallopian tube. So we know this is a muscular tubular structure and it has an inner mucosal layer which is abutting on the lumen, and the lumen you can see is somewhat described as star-shaped or with radial empty looking areas. The lumen doesn't look like a single circular or oval place, but rather like a star-shaped space lined by a very zigzag continuity of the mucous membrane, which will be consisting of an epithelium, obviously. So this epithelium will be will be of a simple columnar ciliated variety, because cilia are required to move to create a tubal wave of fluid, of how should we say, waveform movement of cilia, which will allow the ovum which falls into the tube to continuously move towards the uterine fundus rather than away from it. So that ciliary action creates a wave which allows any contents of the tube to keep moving only towards the uterus. Considering that when spermatozoa enter the tube in the process of ejaculation, when they literally have to climb up a female uterine tract and then climb against or swim against the current of this ciliary action. So what we have to see here is that you have a simple columnar epithelium with cilia. We will look at the details of that in the next picture. And the whole epithelium is thrown into a primary level of fold and then a secondary level of fold, and there probably will be a tertiary level of fold. So there's so much folding of the mucosa column itself that gives a very typical star-shaped or tree branch shaped, leaf-shaped structure. But that's it's not structurally. The empty space is in the form of that primary, secondary, tertiary layer of folding of the mucosa. That's how we recognize the tube. Secondly, it's a small dimension structure. So you can see the whole uterine tube in medium magnification in one field itself. So the entire lumen will be visible, and there will be a lamina propria coming in which will be supporting the mucosa, bringing in the loose connective tissue or dense to medium connective tissue, which contains blood vessels, lots of lymphocytes, nerve fibers, lymphatic, whatever. The point is, you may not be able to differentiate all of them very clearly, but you will be able to see some small capillary cut structures in the lamina propria, bringing the supply, supporting the mucosa. Underneath of that, we will see the muscular layer, which you can you see? It's all cut in LS, which means it is circularly placed smooth muscle, which is supporting the tube. So it's a muscular tube, and you'll see a lot of layers of smooth muscle cut in LS, which is inner circular muscle fibers, inner circular. And then you'll have some interstitial connective tissue in between. So it's not purely muscle, it's not like a thick, it's not like tunica media, but it's all muscle and nothing else. There's also connective tissue alongside with it. Then outside of that, you'll see the LS, longitudinal muscle fibers, which will be cut in not LS of the muscle fiber. Of the muscle bundle, it's a TS, but it is a longitudinal layer of muscle available on the outside of the tube, which will, both of these, which will have some amount of peristaltic movements also. But most of the action is ciliary action as far as ovum transport is concerned. So outside of this longitudinal muscle fibers, we'll have a serosa, because we know that the tube is completely covered by the two layers of the broad ligament, except at its inferior strip where its vasculature is coming in. So that is called the mesosalpinx, right? We will look at that in the next picture. So apart from at the mesosalpinx, the entire outside perimeter of the tube will be actually a simple squamous epithelium or the mesothelium or the serosa. So everything else has been labeled. In this outside layer, where there's a lot of connective tissue outside of the longitudinal muscle, there will be bigger cut sections of blood vessels, venules and arterioles. The smallest cut sections will be in the lamina propria, and the big cut sections will be in the outermost layer of the wall. So when you, this is a better diagram just to show you that this is how the tube is suspended. So from here to here is the mesosalpinx, in which the supplies are coming in, the big cut sections of arterioles and the thin-walled venules and thick-walled arterioles. But if you ignore this bit, we see that outside there is longitudinal muscle, which is basically cut in TS, smooth muscle cut in TS. Then you have the inner circular layer, which is smooth muscle cut in LS, all of this, right? Dash-shaped nuclei, they will be intracellular. Inner circle muscular layer. Inside of that, there will be a lamina propria, pale pink, with a few small vessel cut sections and connective tissue basically. And then there will be the mucosal folds. Look at the extent of branching. This is the main lumen, right? And it's got a primary level of branching and a secondary level of branching and a tertiary level of branching. So the mucosal fold is going into a zillion zigzags. You don't see a lumen as such, which is why you'll get confused if you're thinking of a tube and you're not seeing a clear lumen. It could be confused for any gland, but you look for the continuity of the lumen. There's only one lumen, and it is the one which is extending. This lumen itself is the one which is here. right up to the end. It's one continuous space, but with tertiary level of folding of the mucosa. The interstitial connective tissue is non-specific, like the same anywhere. The serosa here, if you can make out, is a single line of mesothelium. It is a locuboidal as far as this picture is concerned, and it is nothing but the layer of broad ligament which is covering the tube, and it will be secretory in nature, contributing to the peritoneal fluid of the pelvic cavity. So I think we've got everything in this picture, easy enough. If you see it at high magnification, for discussion we could, you would see that each of the mucosal folds is composed of these columnar cells, right? And in the core of each of these mucosal folds will be the lamina propria. So this is very high magnification. You see some blood vessels also very correctly. So here you see columnar epithelium, tall cells. They seem to have a fuzzy surface, right? So that is the ciliated columnar, and oval longitudinal dark nuclei towards the base, typical columnar epithelium. But apart from that, if you look at it at very high magnification, see lovely cilia here, and see they are not microvilli. It's very, very important to remember that these are ciliated cells, and this is the whole cell is from here to here, and its nucleus is here, right? But in between we'll get some cells which do not have cilia, but which rather project more into the lumen. These are secretory cells, also called PEG cells, PEG, PEG cells, and they secrete some amount of nourishing fluid for the upkeep of this ovum with its corona radiata as it travels through the tube towards the uterine lumen. So the diagrammatic view of it, please draw cilia, draw lots of cilia from the surface, and inside the lamina propria you will see fibroblasts, you will see some vessels, and so on and so forth. But you will also see these PEG cells only at very high magnification, which are projecting into the lumen, more projecting into the lumen, and which do not have these cilia. These are cilia, these are non-cilia. So the difference between a columnar cell and a PEG cell. So they project further, they are secretory in nature, and they are a different cell type than the simple columnar ciliated cells. There is a third type which is called an intercalary cell, which is not visible here. Maybe it will look something like this. It won't have cilia, and it won't yet be secretory in nature. It won't be so projecting, it won't be so columnar. Be a lower cell. It is similar to a basal cell in any lining epithelium, and its purpose is to create more of the actual functional cells. So an intercalary cell may also be seen in between of these, a few of them, which is like a base population of multipotential cells, which could become either a PEG cell or a ciliary cell as the requirement is, because any epithelium retains a capacity to restore itself. If there is a cell loss from the surface, the epithelium will always have a small population of cells to restore the loss of the cells for any reason, for whatever reason, normal turnover of cells, abrasion, damage, anything. So no damage is likely within the fallopian tube usually, because just an ovum which is going to be floating along, surrounded by its corona radiator, and the ciliary action will move it along, and the secretions of these PEG cells will nourish that ovum till it arrives in the uterus. If it gets if it has already gotten fertilized and it nidates and a pregnancy continues, then the nourishment is taken over by the uterine lining, which we will look at later. So what you need to remember is that the fallopian tube has this very, very much folded mucosal membrane. This is a very nice thin cut slide, very beautifully stained also, so you get to see the cellular architecture so well, and basically showing you how the PEG cells are projecting into the lumen, and they are not the ciliary variety. So the PEG cells are thinner, they seem to be projecting more into the lumen, right? And they are secretory in nature, the PEG cells. So a basement membrane, where all epithelium has a basement membrane, simple columnar epithelium, yes, all of these are columnar cells. Inner circular smooth muscle, which we saw, right? Connective tissue in the lamina propria. So you see the folding is such, this layer folded upon itself and come back here. So the lamina propria is pretty narrow, but very clear architecture of the cells is visible here. So now let's go to the next organ, which is the uterus. Now I put this here again for you to correlate that under the influence of the female reproductive hormones, both the organs, the gonad, which is, and the muscular sac-like receptacle for the fertilized ovum, which is the uterus, will respond to different phases of what is happening. And these phases are constituted by the overview or the overcommand from the pituitary, right? So there is a gonadotrophin releasing hormone from the hypothalamus. Then there is a luteinizing hormone and adrenocorticotropic hormone. And what else? There was an interstitial cell stimulating hormone in the males. These are released by the pituitary to influence the distant organs, which will then, under that influence through the bloodstream, progress through a follicular development. And this follicular development is happening in the ovary, and this endometrial development is happening in the uterus simultaneously at the exact same phase of the menstrual cycle. And ovulation is a critical event. It's a watershed event where things will change. So that when an ovum is released, this day 14 of the cycle, the development of the uterine lining also suddenly takes off in a very remarkable manner, and for the remarkable purpose of preparing this thickness of endometrial lining for the nidation or the nesting of the embryo, if and when it's formed. And this remaining item inside the ovary, after the ovum is shed from it, also undergoes a change. We talked about it in the last class, where it will convert into an extra hormonal structure or organ, an extra endocrine organ called the corpus luteum, which, if there is a fertilization of this, will get stimulated to form the corpus luteum of pregnancy and become quite a dominant thing, which has to sustain this implantation, keep up this uterine thickness of lining, and prevent it from shedding in the next menstrual cycle. So it's very critical to get this hormonal balance right when a pregnancy happens. If a pregnancy doesn't happen, then the default mode, the default pathway is that this corpus luteum becomes a corpus luteum of menstruation. It regresses, it withdraws, or rather it stops secreting the hormone which supports this proliferation, and this secretory phase of the endometrium, not having sufficient hormonal support, will start regressing. So in the late secretory phase, this portion of the endometrium will contract and then shed. So we will look at that, how it looks like in the slides of the uterus that we have, but always remember that this is paralleling whatever is happening in the ovary, which is paralleling whatever is happening in the hypothalamo-hypopituitary axis, to some extent supported by whatever is happening in the adrenal cortex. In that adrenal cortex, there were 3 layers. There was a zona, you remember, fasciculator, reticularis. So reticularis, the third innermost layer, was the one which was producing the sex hormones. So that produces all 3. From the cholesterol molecule, it derives estrogen, progesterone, as well as testosterone. But in the female, because of the ovary producing lots more, there is an extra amount of estrogen floating in the blood, which does the support to the entire proliferative phase. But at the addition of progesterone, which is coming from corpus luteum, you have the impetus, the boost for the secretory phase of the endometrium. Please remember all of this. So the uterus as an organ by itself, it has an innermost lining which we call the endometrium, and then it has a muscle layer, thick muscle layer, which we call the myometrium, and an outer fibrous tissue outer lining package holding it together, which is called the perimetrium. Peri is around. So this would be peri, myo, endo as per the diagram. Myometrium is a very dominant layer because this is basically a muscular sac or a muscular tube. Compare it compared to its outer dimensions, its inner luminal area is very, very small, unless it gets pregnant, at which time it undergoes changes. But otherwise it's a muscular tube, and the muscle is smooth muscle, very, very important, because it is going to be participating in and causing the birth of the fetus at the end of pregnancy. So the myometrium, it's the way it's laid out, the way it is coordinated, is extremely important when a pregnancy happens. But until that point of time, it's only the endometrium which is undergoing these cyclical changes. Nothing happens to the myometrium and the perimetrium during the normal adult changes of cyclical monthly changes of menstruation. It's only the endometrium which responds. So when we look at a slide, or when we try to identify a side of uterus, we are first looking for the endometrial features, but we are also looking to see that it is a muscular organ, because the myometrium will dominate in terms of the full thickness of the wall, right? In terms of the full thickness, the wall of the uterus is from here to here. The myometrium will be dominating, right? So when we take a bite for a biopsy, we'll get a small bite. You get some endometrium, and you get this much of myometrium. So you'll only see the luminal side for endometrium to try to determine what it is. So the epithelium is simple columnar in continuity with fallopian tube. Simple columnar epithelium. Before menarche, it is also ciliated, just like fallopian tube. But once menstruation starts, layers and layers of cells are going to be shed every month, and therefore there is not sufficient time for cilia to grow, and there is no function for cilia within the uterus. So thereafter, after menarche, we don't have ciliated epithelium, we simply have simple columnar epithelium. The lamina propria, or the endometrial stroma, contains lot of stromal cells, lots of blood cells, and simple tubular uterine glands. You remember this because we will look at the architecture of the tubular uterine glands and how it changes from the beginning of the cycle to the end of the cycle. So the first thing to remember is that there is a zonation even in this lining of the uterus endometrium. There is a functional zone, which is the one which will be shed during menstruation. So we call it the zona, or the stratum functionalis. It is 2/3 thickness of that endometrial wall, and it will be sloughed off. Whereas the basal zone, or stratum basalis, will remain. It's continuous. You never lose it. It's always there. And that is firmly attached to the myometrium. This is very important. We'll come to this point. And it is retained during menstruation. So that bottom 1/3 stays, and the top 2/3 gets shed in that 28th cycle. So cell growth from this bottom 1/3 is what will sustain and restore the functional layer on a continuous basis. So it's a very high metabolism, high activity lining in the sexually mature adult female. To keep this high grade of metabolism, this will high turnover of cell division, cell replacement, cell specialization, there will be a lot of arterial supply. So in that basal zone, stratum basal, there will be basal or straight arteries which will supply it. Then in the functional zone, there will be spiral arteries. The artery itself, the spiral artery, is located at the junction where the basal becomes functional. It extends into the functional, supplies it, then loses that tip. The arterial tip is lost in the bleeding, and the short basal part remains, which again grows back every month. And in the surface epithelium, just under the surface epithelium, there will be a capillary plexus which is being kept alive, which is being fed by these spiral arteries. So to understand what we see next, this is what the uterine lining will look like. So you will see a stratum functionalis, which is from here to here, and then from here can you make out that the base, the interstitial tissue, the lamina propria, is looking a little denser pink compared to this. This is light, this is dark. That's about all you'll be able to make out the difference between the functionalis and the basalis. So when you have the endometrium is ending here, this is where the endometrium ends and the myometrium begins. So if you look at the wall of the uterus, there's so much thickness, is muscle, smooth muscle, different bundles, and they seem to be cut in different directions, though they're supposed to be an inner circular and an outer longitudinal. You may be seeing some amount of interlacing bundles, but they're supposed to be more dominantly inner circular arrangement and an outer longitudinal arrangement. After pregnancy, it becomes a little more three-way, in the sense it is obliquely cut in all directions. But before the first pregnancy, it more or less follows a inner circular outer longitudinal layer. The smooth muscle is cut in LS here, and the smooth muscle is cut in TS here, cross-sectional, because these are longitudinal bundles and these are circular bundles. But the point to remain here is, again, there's a lot of interstitial connective tissue, some amount of elastic fibers also, and good amount of blood vessels. That's important. Smooth muscle, usually wherever else you see it, it doesn't get such a great blood supply, right? But in the uterus it does, huge amount of blood supply. See, smooth muscle forms your stomach, smooth muscle forms your urinary bladder. But comparatively, the amount of blood vessels available is maximum in the uterine smooth muscle. And the branches of these big vessels are the ones which will get into your basalis layer. So from here to here is endometrium, and from till here is basalis layer, where you can see that the uterine glands cut sections you're seeing as oval cut sections, close together, and lot of close together arterioles and venules. Yeah. And then once you get into the functionalis layer, or into the more superficial towards this, the lumen layer, the glands are becoming more far apart, more longitudinally placed. There's a lot more lamina propria in between, and you still see lots of blood vessels. Alright, lots of blood vessels, which will be, both of which, gland and blood vessel, which will become more dominant and more typical. Their look will change once you get into the next phase. But before that, let's look at what the phases are. Now, when a patient comes to you, or when you're dealing with gynecology in clinical practice, what the patient is able to tell you is from the first day of bleeding. So clinically, day 1 is the beginning of the menstrual, of the entire endometrial uterine cycle. But in terms of histology, or in terms of development, or in terms of physiology, day 5 is when that whole menstruation is over. You come to zero base, and from there the endometrium is again continuing to grow out. So this should technically be day 1 or phase 1. From here to here would be the first phase. So physiologically this is the first phase, but clinically we say the menstrual phase from day 0 to day 4 is the first phase. So the clinical beginning of the cycle is actually the end of the total endometrial cycle. At the end of this menstruation, the functional zone has been sloughed off, only basal zone is remaining. So you don't get to see, in fact, you will only get to see till here, right? There's nothing beyond this. At this point, the uterus stops, and these glands will be open, and the arterial ends will be open. Now, all of this from here to here would have been shed. It will be detached from the surface and completely fall into the lumen, leaving only this much of endometrium, right? So that would be phase 1, menstrual phase. Then you have the proliferative phase, which is the estrogenic phase, which is day 5 to 14, because ovarian follicles are growing and secreting estrogen. So this functional zone proliferates and regenerates from the basal zone. So that little zone which is left will now have a lot of material flowing in, and those glands will be rapidly growing, and the arteries will be rapidly growing and building up the whole height of the endometrium. So these glands are initially straight but become slightly wavy towards the end of this proliferative phase. Spiral arteries, which are there in the basal layer, grow with the endometrium. They are difficult to see because they are not yet coiled. They will become coiled in the next phase, we will see. So what we saw was a endometrium which consisted of a functionalis layer and a basalis layer. In that endometrium, we see a lining epithelium which is simple columnar, non-ciliated usually. Lamina propria is there, coiled arteries are there, but they don't look coiled, they just look like cut sections, and you see uterine glands. These are actually arterioles with a good amount of muscle in the wall, right? If they didn't have this muscle, they would be venules. So uterine glands which are seen, which are more or less longitudinally cut very often, otherwise oval round cut. And these are starting from this basalis layer. And here the blood vessels are communicating or getting in from the muscular layer, which is called the myometrium. And in the myometrium, you have smooth muscle cut in longitudinal bundles as well as in cross-sectional bundles, lots of them. And you have interspersed with interstitial connective tissue and larger bore blood vessels. You see bigger sections of arterioles and venules, and quite a lot of them. Right, these will be venules, these will be arterioles. So this was called the proliferative stage, or the second stage, or the stage day 5 to 14. Right, that is followed by a secretory phase or luteal phase, which is after day 15 onwards. Day 14, we take it as a typical ovulatory day. The thickness of the endometrium becomes even more increased, the glands become enlarged and they become tortuous and coiled on each other and very secretory in nature. The spiral arteries lengthen, become even more coiled, and they are easily visible because they are spiral. Because the artery itself is a spiral on itself. When you take an LS through it, it looks like a zigzag lumen, right, or a saw-toothed lumen. Saw is a saw which cuts wood, right? So it has a serrated edge kind of thing. So the cut section of the glands and of the coiled arteries will look like a zigzag, and that is typical of the secretory phase or luteal phase, or third and final phase. So the stromal cells, the cells in the stroma, in between the glands and in between the blood vessels, are the lamina propria stroma. Cells in that are now called predecidual cells. They are large and pale, and they have a lot of glycogen and lipid in the cytoplasm, and they are located in just under the surface epithelium and around the spiral arteries, and they are going to be nourishing to a ovum if it nidates, right? So if there is a fertilized ovum which is trying to bury in and locate itself in this endometrial thickening, these stromal cells are going to supply this glycogen and lipid and allow it to, the embryo is going to rapidly cell divide and start differentiating. So energy must be provided, and these stromal cells are therefore called predecidual cells. If pregnancy occurs, then we call them decidual cells and they become more prominent. If pregnancy does not occur, the same cells are continue to call predecidual, and they are sloughed off with the menstrual fluid because they are in the layer, the functionalis layer. They are right under the surface. They will be lost. So the extra thing which is noticeable in secretory phase, apart from thickness of endometrium, enlargement of glands, corkscrewing of the spiral arteries, is stromal cells which have become very dominant and large and filled with glycogen. They won't stain very well with HE. So if you do a glycogen stain, they become very easy to see. Remember, they are called predecidual cells unless a pregnancy happens, in which time we will call them decidual cells, and they will be retained and they will contribute towards the fertilized ovum. So this is what we meant by saw-toothed appearance, right? In a secretory phase, the gland has become coiled on itself, and therefore in cut section it appears zigzag. And you may see some secretion, it may not be pink in color. This is a painting. Can you see? The author is here. So, but don't worry, you probably may not see any secretions in the glands, or you may see, it will look more like this, right? The gland will look hypertrophied and tortuous, and the secretion will, there may be something visible inside of it. This is a functionalis layer. So look at the proportion of the functionalis layer. It's become much bigger compared to the basalis layer. Even in the basalis layer, you're seeing that the vessels and the glands are looking very wavy in cut section. Vessels in this picture are looking just like TS, but this would be, all these three together is a singular spiral artery, the basal part, the coiled part of the artery, which is going to remain in the basalis layer, and then it's good. Cut sections of it are going to accompany the glands. Actually, there will be a lot more arteries, and they will be in these areas. Plus, you'll see venules and capillaries. The myometrium will start here, and again you'll see TS and LS of smooth muscle with lots of blood vessels alongside. So what we do when we put it as a spotter is we try to get you a feel like this. We're showing you very little bit of smooth muscle at the bottom, but we're showing you the entire thickness of the lining epithelium. So once you see the typical saw-toothed appearance, you know that these are coiled glands. They look like they have a simple columnar epithelium, so it's likely to be uterus. The premenstrual phase, by the time you come to the last few days of the secretory phase, is day 26-28, because again, day 0, bleeding is going to start. The estrogen and progesterone secretion, which is happening in the ovary because of the corpus luteum, is withdrawn. Till now, the estrogen progesterone is at a peak, but after waiting for this 26-28 days, if fertilization has not happened in the ovum, the ovarian corpus luteum regresses because hormonal support is withdrawn. The whole endometrium gets compressed. This whole thick endometrium gets a little compressed because there is no support, and there is a constriction of the spiral arteries. So the overlying tissue, when an artery constricts, the tissue stops getting supplied with blood and it dies. The functional zone, ischemia, causes the tissue to become necrotic. Necrotic means it dies and it becomes disrupted and broken up. The spiral arteries, after that constriction, they reopen and blood flows into this ischemic tissue, and this bleeding into the stroma can be seen. So if you see a slide of a menstrual or just a premenstrual phase, you'll see this blood in the stroma. There's RBCs spilling out. They're not inside the vessel, but they're in between the glands and the vessels, and that will be part of what is going to be shed. So this cycles of compression and reopening leads to degeneration of the functional zone and then initiates menstruation. This must happen, a tightening and then a bleeding, and then a tightening and a bleeding, for that whole layer, 3/4 layer, to die, to become necrotic and to slough off, and therefore be lost in the menstrual. So in a late secretory phase, you're seeing depletion of everything, and you see RBCs pooling outside of the, in between the stroma, you'll see a lot of loose RBCs. So stratum functionalis looks a little disrupted. You don't see the sharp sawtooth, but more wavy, but still the uterine glands are coiled. So it is definitely not a proliferative phase, it is a secretory phase, but because of the loss of architecture of the vessels and the RBCs visible inside the stroma in between, they're not staining pink like normal connective tissue, but a lot of in between bleeding. If you see it at high power, it will be much better visible. You see a lot of blood, and in the connective tissue of the basalis, where is your basalis? In the connective tissue of the basalis, the basal layer of the coiled arteries and the coiled glands is maintained, right? So a lot of cellular proliferations, a lot of WBC is going in. You must remember that when this layer is preparing to shed, it's being open, it's being opened out to any possible pathogens which are in the lumen. This is the lumen of the uterus. So there will be a lot of WBC support. There will be a lot of lymphocytes, etc., floating in here and being ready, because it's a very vulnerable time as far as any infections or foreign proteins are concerned. Very easy for them to invade. So it is a time where a lot of immune response is also happening at the basal layer. Can you make out that this myometrium is not looking very well demarcated from this endometrium, right? Basalis is from here to here, and the myometrium is just underneath it. So you must remember that the base of the arteries is starting and is in between these layers of smooth muscle. So in between bundles of smooth muscle is the branch of the artery which is coming in to the endometrium, right? The branches have to come in from the outer wall to the inner wall. You saw blood supply of uterus yesterday, right? Uterine artery, whatever branches are coming from outside, from perimetrium into myometrium, then into endometrium. That's how it will go. So where the artery branch is branching off from the myometrium to get into the endometrium, it is between bundles of muscles. The artery is going, and this is extremely important to stop the bleeding, to end the menstrual cycle. After this late secretory stage, there's a compression of the endometrium, there's a withdrawal of hormonal support, there is a compression of the coiled arteries, which will cause a necrotic degeneration and death of all this tissue. Then there's a release with bleeding into it, then again compression, several cycles of that. This whole layer, functionalis, the whole functionalis layer will die and therefore get shed. These remain open, the glands, because there's break of tissue and falling away, so the openings of the glands will be open, the arteries will be open. There needs to be a lot of immune boost and support at this point of time, and the base of these arteries will be in between smooth muscle bundles. So after that whole sloughing is over, these arteries will get constricted by some amount of contraction of the myometrium, which will limit the bleeding and prevent that patient from exsanguinating. not patient, normal adult female. So that's an important histological feature built in, and it is even more important after delivery of the baby. So when the baby is shed and the placenta has detached, then another whole bunch of endometrium will be shed along with that, and these uterine contractions will allow these coiled arteries to they will squeeze the coiled arteries between the bundles and prevent too much of bleeding from the mother. So when you look at it under hyper, you see how the glands are, right? This is all simple columnar epithelium only, right? And these are the contents, with secretions and simple columnar epithelium, right? So what is happening at the end of the proliferative phase? This is what your columnar cell looks like with a few microvilli, and you have the shape of the gland. These are the lining cells. These are lining cells. Then the cell becomes a little bigger, and the infranuclear area develops a little more of endoplasmic reticulum and some lots of mitochondria, you can see, right? And the surface becomes a little narrow compared to the base, and the whole gland is becoming more wavy, coiled on itself. And when you come to late secretory phase, the gland has become huge. The width of the gland has, the dimensions of the gland have become very big, and the cells have also, the nucleus has been looking large, and you have secretory vacuoles at the luminal surface, which will be shedding secretions of the uterine glands, lots of uterine secretions which will be falling into the lumen and washing off along with the blood and everything else that is shed. So in the menstrual phase, the functional zone becomes necrotic, it's sloughed out. The flow contains blood, tissue fragments and uterine fluids. Only the basal zone remains, from which the functional zone will get regenerated. So this is what we called the clinical stage 1, but actually is the physiological last stage, where the post-secretory phase is the menstrual phase. So in the menstrual stage, you can see lots of RBCs everywhere, and there will be RBCs even in between, and the gland structure is becoming minimalized. It's not so huge and so dominant, but much of it is already being shed. You'll see lots of fragments of the stroma, lots of blood clots, lots of erythrocytes, and you'll see that the basal layer, this is a muscle, this is myometrium from here to here, all this is muscle, right? So the basal layer of the gland is intact. The basal layer doesn't seem to have changed at all, whether it's proliferative phase or secretory phase or premenstrual phase or menstrual phase. The basal layer of glands is more or less the same. The smooth muscle, here in this particular section, we are seeing more of smooth muscle in the field because the whole endometrium itself has become short. From here to here is endometrium, then it's over. So that whole height of endometrium has come down because the surface layers have been shed, and you're seeing mostly the basal layer, basalis layer with interglandular lamina propria. You're seeing the coiled arteries, you're seeing the gland lumen filled with blood, superficial endometrium where epithelium has been shed. So you're not seeing any epithelium here because all of that is falling into the lumen and going to get washed away. So this is the menstrual or the last. I don't think we have this slide, but this is the fourth stage. So what do we have? The proliferative phase, okay, where you have an endometrium, myometrium. If you look at the same thickness of wall, you'll see a lot more muscle and lot less of endometrium, and it has a surface which is slightly in and out, and it has simple tubular glands, and it has a basalis layer where the lamina propria stains more pink, it's a little darker, and you see lots of arterial cut sections. Then we come to secretory phase. You see that comparatively the thickness of the endometrium is from here to here. So the endometrium has become so thick compared to so thick, almost doubled, more than doubled in its thickness. And at the base, basically you'll recognize it by this sawtoothed appearance because of the coiled arteries and the coiled glands being cut in LS. And some of them you'll see them opening to the surface. You see lots of blood vessels in between. When we come to the pre-secretory phase, they are not looking so zigzag, a little less zigzag, more coiled, seems to be more spaces, and you'll see some amount of sloughing into the tissue. The basal glands are very, very coiled, and there is dense lymphocyte infiltration into the stratum basalis. Alright, and here this is the same as this actually. It's looking almost the same, but the differentiation is all the RBCs you're seeing at the surface. So you're seeing sloughing, you're not seeing a formed endometrium, right, an endothelial lining. Then it is menstrual phase. Easy enough to recognize. Everywhere else it's intact. The surface, the luminal surface is intact. Here it is not. It is disturbed. So you have an epithelium and then you don't have an epithelium. There's no epithelium here, right? Because that part of the gland and of the blood vessel, the surface is shedding. And typically lots of RBCs in the lamina propria, inside the gland and inside the lumen. Lots of RBCs. And you'll see again the same spiral artery branches. Here this is more like arterial branches, they're containing the blood, and gland bits. And the basal, stratum basalis is looking similar to this or similar to this, and you have the myometrium. So these 4 phases, I think we have only 3 slides. The way to recognize them is the comparative thickness between endometrium and myometrium, the straightness of the gland, the amount of space available in between, and what is there in the lamina propria, how cellular it is, whether RBCs are there in it or not, and the sawtooth appearance typical of the secretory phase. So between proliferative and secretory, usually you should not be able to make a mistake. So again, just to remind you that this correlation, what's happening in the ovary, what's happening in the uterine lining, what's happening in the pituitary, that correlation you have to keep in mind at all times to be able to remember it and to be able to interpret next year whether that's normal or abnormal. That is the whole crux of it, whether this is within normal range for a physiological cycle or whether it's going out and becoming pathological. That decision you will make, the clinical decision, based on how strong your correlation is between about the whole hormonal support axis. Alright, so we will close this class. I think time is also up. And in the next class, I think we'll catch up with, I remember taking a class on testis epididymis, but I think the visual did not show. So let me look at the schedule, and in the next we'll catch up and finish the male reproductive tissue, and then we'll finish the remaining female reproductive tissue, so that it is correlating with all the organs which you're seeing in the pelvis and which you're studying in gross anatomy. So bye for now, and I'll see you on Saturday.